Hello guys, welcome back to Inside Mathematics, and in this video we are going to look into this question that I gave you on our previous video. So let us take a look into the solution. So given that sine theta is equals to 4/9, find cos theta and tan theta. There are three different ways of solving this question. The first way is simple, of course. It is by using Pythagoras theorem and trig ratios, of course, where we are going to say sine theta, especially when we are using this concept of SOHCAHTOA. So when you are using this concept of SOHCAHTOA, it suggests that sine theta is equals to opposite over hypotenuse. So given sine theta is equals to 4/9, it means the opposite side, if we are to draw right-angled triangle, and this is our theta, we believe that the opposite side is 4 and the hypotenuse is 9. So here, this is the missing side. Why are we considering to look for a missing side? Because if you are looking for cos theta here, the SOHCAHTOA suggests that cos theta is nothing but adjacent over hypotenuse. Adjacent over hypotenuse. Of course, we read from this side going this side. So by this theorem only, it means the adjacent is x. We don't have the value of x here. Okay. To be cos theta is equals to x over hypotenuse, which is 9. So we need to do Pythagoras theorem, where in Pythagoras theorem you can choose either this a, b, c, or you don't put anything but you apply the general formula where c square is equals to a square plus b square. And everyone knows that c square represents the longest side, where the longest side in this case is 9 square. Okay, so 9 square is equals to 4 square plus b square, where b is going to be our adjacent square here. So here we're going to take this 4 to the other side. So we get 9 square minus 4 square is equals to x square. So 9 square, when we are squaring 9, we get nothing but, so when we are squaring 9, we get nothing but 81 minus 16 is equals to x square. And 81 minus 16, we get nothing but 65 is equals to x square. So we square both sides. Here we are going to get square root of 65 is nothing but x, because we don't have an exact value of 65. So after doing so, it means we are agreeing that cos theta, that's what we agree, adjacent over hypotenuse, as we can see here, adjacent over hypotenuse, and x is representing the adjacent. So the value of x is now root 65 over hypotenuse, which is 9. So we are done here. Now we need to look for tan theta, okay, where tan theta is nothing but, according to SOHCAHTOA, it's opposite over adjacent. So opposite over adjacent. So here we are saying tan theta is equals to opposite. Opposite is nothing but 4 over adjacent. Of course, adjacent, we already find adjacent here. This is where we get adjacent, which is 65. So root 65. And according to our laws of radicals, we don't allow denominators of square roots. So what we need to do is to rationalize the denominator. So when we do difference of two squares, here, we need to rationalize the denominator. So we end up having tan theta is equals to 4 root 65 over 65. That's the answer we'll get.